Polyphenol are often introduced like the rock stars of the nutrition world: flavonoids, tannins, stilbenes, anthocyanins, armed with free radical fighting powers and a reputation for warding off everything from cancer to cognitive decline. They're the bioactive jewels in your blueberries, the reason behind green tea's cult following, and the justification for drinking red wine for your heart. But there's a lesser-known twist to this story. Under certain conditions, polyphenol don't just neutralize oxidative stress, they may actually cause it. Yes, the very same compounds lauded as antioxidants can flip into pro-oxidants at high concentrations or in the wrong biological context. It's a nutritional paradox that has scientists simultaneously intrigued and cautious. Like many compounds in biology, polyphenol are dose-dependent agents, and their effects shift depending on how much you consume, what form they take, and what your cellular environment looks like at the time. To understand this duality, let's take a closer look at their primary role. In modern amounts, polyphenol act as antioxidants by donating electrons to neutralize free radicals, unstable molecules that damage DNA, proteins, and cell membranes. This is part of why polyphenol are associated with reduced rates of chronic inflammation, cardiovascular disease, and neurodegeneration. They also trigger the NRF2 pathway, a master regulator of the body's own antioxidant defenses, leading to the upregulation of enzymes like glutathione peroxidase and superoxide dismutase. In essence, polyphenol are not just antioxidants, they help your body make more of its own. But here's the catch. At higher doses or in certain redox environments, polyphenol can undergo autooxidation, generating hydrogen peroxide or quinone-like intermediates that behave as pro-oxidants. These reactive oxygen species, ROS, rather than being eliminated, can cause oxidative stress, damage DNA, and disrupt mitochondrial function. This has been observed in vitro with compounds like quercetin, resveratrol, and epigallocatechin gallate, EGSG, all of which have shown protective effects at lower concentrations, but cytotoxic or DNA-damaging properties at higher levels. This doesn't mean polyphenol are dangerous. On the contrary, this hormetic effect, a biological principle where a low dose is beneficial but a high dose becomes toxic, is part of what makes them so powerful. Mild oxidative stress from polyphenol can actually stimulate adaptive responses, triggering cell repair, autophagy, and increased antioxidant production. In this way, their pro-oxidant activity at modest levels may actually be one of their therapeutic mechanisms, not a drawback. However, problems can arise when people isolate and consume polyphenol in supplemental megadoses, especially without understanding the surrounding nutritional context. Take EGCG, the primary catechin in green tea. While a few cups of tea a day can reduce inflammation and support cardiovascular health, high-dose green tea extracts have been associated with hepatotoxicity in some individuals. Similarly, resveratrol can modulate inflammation and activate sirtuins at modest doses, but at high concentrations, it may inhibit mitochondrial function or even induce apoptosis in healthy cells. And context matters. In healthy individuals, a short-term pro-oxidant nudge from polyphenol can spark resilience. But in someone with underlying oxidative stress, mitochondrial dysfunction, or impaired detoxification pathways, that same nudge could push the system toward further imbalance. It's not about whether polyphenol are good or bad. It's about whether they're appropriately dosed, well-timed, and consumed as part of a balanced diet. This is why whole food sources of polyphenol consistently outperform high-dose supplements in long-term studies. Berries, olives, cocoa, tea, and vegetables deliver polyphenol alongside fiber, vitamins, and other phytochemicals that modulate their absorption and effect. The body receives these compounds in a time-released, biologically familiar form, not in an isolated spike that may stress the system. So yes, polyphenol can be antioxidants and pro-oxidants. They can protect cells or stress them. But that's not a flaw, it's part of their genius. They teach cells how to cope with adversity, stimulate repair mechanisms, and modulate inflammation, so long as they're not overwhelming the system. In the right doses, polyphenol are molecular teachers of resilience. In the wrong doses, they become overbearing coaches yelling at a cell that's already limping. The takeaway? Respect the dose. Prioritize food sources over pills. And remember that sometimes a little stress is exactly what your cells need, just not too much of it and not all at once.